Have you ever undone something on your computer and then undone it again and again until you went too far? And suddenly you're like, wait, where did my work go? That tiny panic moment that's powered by one of the simplest yet most important data structures in computer science. Today, you're going to understand it so clearly you started seeing it everywhere. There's a very specific rule behind that undo button. It doesn't randomly pick actions. It follows a strict order. The last thing you did is the first thing that gets undone. And if you think about it, that's actually how a lot of things in life work. Think about stacking books. You place one, then another, then another. Now, try to grab the one at the bottom without touching the others. Yeah, not happening. You always remove the top one first. That's the core idea of a stack. A stack is a data structure that follows one simple rule: last in, first out. The last element added in the first one removed. Think of it: a stack of plates, a pile of books, your browser history, even your call stack when running code. They all behave the same way. And in programming, stacks usually have just two main operations: push, add something to the top; pop, remove the top element. That's it. Simple, but extremely powerful. Let's make this more real. Picture a cafeteria. Plates are stacked neatly, one on top of the other. Every time a clean plate arrives, it goes on top. Every time someone grabs one, they take the top plate. Nobody digs through the stack like a raccoon looking for treasure. That would be chaos. Computers hate chaos. Stacks bring order. Let's break it down quickly. Say we start with an empty stack. Now we push some values. And then we start removing. Notice the pattern? The last thing added, it's always the first one out. That's the stack in action. You might be thinking, okay, cool, but when do I actually use this? Everywhere. Literally everywhere. Here are some real examples. Undo, redo systems, browser history navigation, function calls in programming, expression evaluation, like math calculations. Here's a fun one. The reason it's called a stack overflow error is because there's literally a limit to how many functions calls your program can stack. When that limit is exceeded, the stack overflows. Just like piling too many plates until everything crashes down. So yeah, next time you see that error, just because a tower of plates collapsing in slow motion. Stacks are powerful, but limited. You can only access the top. No shortcuts, no skipping ahead, no let me just grab the middle one real quick. If you need flexibility, you probably need a different data structure. But if your problem follows an order like last thing added should be the first one used, then stacks are perfect. Let's lock this in. A stack follows last in, first out. You can only interact with the top element. Main operations, push and pop, used in real systems like undo, browser history, and function calls. Simple idea, massive impact. Now I want to hear from you. Where else in your daily life do you see this last in, first out behavior? Drop in the comments. I'm curious what you come up with. And if this video made things click for you, hit the like button, subscribe to the channel, and turn on the bell so you don't miss the next video. See you in the next one. Bye!